Alright, so we're going to talk a little bit about exponent properties. This is a skill that you guys should have learned in Math 1, but I didn't teach you Math 1, so we're going to just review. Alright, so you have 6 different properties. The first one is for multiplying. So when you have two numbers with the same base, you're going to add their exponents when you multiply them together. So if I'm looking at a to the 7th power times a to the 12th power, they're being multiplied together. So that means I'm going to want to add their exponents, right? So I would just have a, and then 7 plus 12 will give me what? 19. Sorry, that's sloppy. So you have a to the 19th power. So if you look at a more advanced problem though, like when you're multiplying two sets of parentheses together, even though there's no multiplication sign, that still means multiplication. So you're just going to distribute. So you would do 2 times 4, which gives you 8. Then you're going to just keep your next variable, but you're just distributing those two. So you're multiplying the same things together. I guess distributing is not the best word. So you're just multiplying each like term together. So the x squared times x cubed, you would keep the x and then just add their exponent. So 2 plus 3, the exponent would be 5. Then keep the y. You only have one y, so that would be squared. Alright, so these are somewhat simple examples. They correlate with the examples on your worksheet. So that's multiplying. When we look at dividing two numbers with the same base, you're going to subtract their exponents. You always subtract, so you would put the top first and then minus the bottom. So it would be 6 minus 2. So I'm going to keep my base of 10, then I'm subtracting my exponent, so 6 minus 2 will give me 4. Now if your base is actually a number, then you really can do 10 to the 4th power, which would be, I think you're just going to have 4 zeros, so it would be 10,000. Alright, now if that was a variable, then you would just leave it at x to the 4th or whatever. So on the bottom, again, we're going to do like terms. So 6 and 2, they're both numbers, so I'm just going to divide them. 6 divided by 2 gives me 3. Then I'm keeping my base, my variable, and then 2, and if it doesn't have an exponent, that means the exponent is 1. So when I do 2 minus 1, it's just going to be 1. So I really don't need to put that exponent, but I can if I want to. So my answer would just be 3r. Okay? A power. So when you have a number to a power and then raised to another power on the outside of a parentheses, then that's when you're multiplying those exponents together. So I have x squared and then that whole thing to the power of 3. So I'm going to keep my base of x, and then when I multiply the exponents, I would get 6. So my answer would be x to the 6th power. Now this is where distribute is the right word. So I'm going to distribute this exponent on the outside to everything inside my parentheses, even the number, right? So this is going to become negative 15 to the 3rd power. This is going to become h to the 9th, and then to the 3rd. So I'm going to need to multiply those exponents together. And then this is going to become k to the 7th, and then to the 3rd. So again, I need to multiply those exponents. So when I write that out, I would have negative 15 to the 3rd, and then h to the 9th, to the 3rd, then k to the 7th, to the 3rd. So I need to multiply these exponents together, and then I just need to solve what is negative 15 to the 3rd power. So normally I would say whenever you square a number, it's going to be positive, but when you have a cube, if your number is negative, it's going to be negative. So 15 times 15 times 15 basically, but your answer is going to be negative. And that's going to give me negative 3,375. Then I'm going to keep my base of h, and 9 times 3 gives me 27. Keep my k, 7 times 3 gives me 21. Okay? Next one, negative. So whenever you have a negative exponent, you have to flip it to its inverse reciprocal, or its reciprocal, whatever. So if you just have like a number here and there is no fraction, it's like it's over 1, right? So if I have x to the negative 3rd, when I flip that x is going to become x to the positive 3rd, but that's going to go on the bottom now. And that invisible 1 that we had is what goes on top. So this went to the bottom, and this goes to the top. Everything just flips, and now after you flip it though, you should only have positive exponents. That's the whole point of flipping it, is to get rid of negative exponents. So if we look at the second example, all of this is positive, so this is not going to flip anywhere. This is going to stay on top of my fraction. 4x third to the third power. But this y negative 2 needs to change. So if it's on the bottom, it needs to come to the top. So I'll just add that up top, but now my exponent is positive. And now everything is over 1, so you really don't need a fraction anymore. And your answer would just be in one line. Okay, we're almost there. 0. So any number to the power of 0 is 1. This one is simple. So x to the power of 0 is 1, right? I have a 0 power here, y to the 0 power. So when I rewrite this, I'm rewriting everything else the same. But I don't even need to rewrite that y to the 0 power because I know it's 1. So I'm just not even going to put it. And then I'm just going to have, this is a 2, by the way. But I'm just going to bring down my z to the 5th, okay? So whenever you see anything to the 0 power, it's just going to be 1. So that means you don't really have to write it unless you just want to write that times 1. But it doesn't really mean anything. And the last one, a radical. This might be the trickiest one. I just think about it as like drawing an arrow around. So anytime you don't have a number in this radical, it's a 2 there, and you're taking the square root. So to turn a number with a fraction, okay, well that's this one. I'll do this one first, I guess, since that's what it says. As its exponent into a radical, it says bring the denominator, the bottom number, around and drop the numerator down. So if this is my fraction and my exponent, I'm going to bring this 3 around and drop this 2 down. And what that means is it's going to become in a radical, right? So when I bring my 3 around, it's going to go on the outside of my radical. That is ugly. Sorry. And then when I drop my 2 down, it becomes the exponent for my base, right? So now x to the 2/3 power is the same as the cubed root of x squared. Okay? Now the reverse. So if you want to reverse it, you're going to bring whatever number's out here back around, push this up and get rid of the radical. So x is still my base. My 3 gets pushed up to my numerator, and my 2 falls underneath. So I just brought this 2 around, pushed up my 3, and put it on top, and now my 2 that was out here is on the bottom. So it's just the opposite of what happened here, right? So I brought this one around clockwise and dropped this down. We were going from fraction to radical. Going from radical to fraction, though, you bring your whatever number's out here around counterclockwise and push the exponent up, okay? So you guys can finish the paper that you have, and then try some EOC questions.